is a video for Opt3 Day 5, Day 5B, Level 3, looking at some strategies to use to complete this mastery assignment. So there's multiple parts to it. So the first part is asking you to click on this link to go to the Desmos graph and complete the exponential regression. Okay, so they have the table already filled out, and you have to complete it right here. So I'm going to use a different example to show you how to do an exponential regression. So here's a table with some data. So this is basically the equation that you're going to type for an exponential regression. Okay, so it's y1, the little tilde, a times b to the x1 power. Okay, so I have it written over here as well. So this is the thing that we have to use. We have to type that in. Okay, so in this example, it shows you, it gives you a bunch of information. It gives you A and it gives you B. So A is like your initial amount at year 0, for example. You can see it's the y-intercept. And B is the 1 plus R, as we are used to seeing. So you can see this is about a 6% increase each year, if that was the case, if this was in years. So then just remember that that B represents 1 plus R. That's your percentage. Okay. You're also going to see the R squared number when you do the regression. You can change that to a percentage, and you can think of that as the exponential model is explaining that much percentage of the variation of the data. So for example, if R squared, if you find your R squared is like 0.71, then it explains 71% of the variation of the data. The higher it is, the more likely it is to be a very accurate representation. Okay, so looking specifically at these questions, okay, you have to write that equation for the exponential function after you do the exponential regression. So you have to type this in. It will give you the A and it'll give you the B. So I'll just make something up. 215 for A, and B maybe is like 1.07. So then you would write the equation y equals 215 times 1.07 to the x. We can drop the ones and we can put the equal sign back in. Okay, actually it says round to the nearest hundredth, so that's actually correct. Okay, that's fine. Okay, then you have to look up what the R squared value is, and then basically just use this sentence structure that I gave you. The exponential model explains 71% of the variation of the data. Okay, and then they start to talk about an expense ratio. Okay, and also it says that they invest a different amount. So first of all, the expense ratio is going to affect the 1 plus R. So you have that 1 plus R number. In my case, it was 1.07. You're going to subtract the percentage of 0.24, but we got to change it to a decimal, so we have to move it to the left, 0.0024. We're going to subtract that from the original that they had. Okay, so and you're also going to put in your initial amount with this new thing. So whatever number you get here, it's going to be your new number here to the x power. Okay, then they ask, what are the limitations of using this model to predict the future fund prices? I mean, it's just, I want you to think about, like, do you think that a model like this is going to be consistent? Do you think that You can assume that it's going to continue on in the same way. Just think about it, write your answer. Okay, this part's pretty self-explanatory. You just have to watch this video, and they literally tell you the answer to number 5 in the video, and they pretty much explain almost everything in this one in the video. Okay, and then you have to do another Desmos graph. So you click on the link. Okay, and they give you a scatter plot that shows data points for the daily prices of the fund IWO and the Russell 2000 benchmark. Complete the linear regression equation below to find the line of best fit for the data. So this is a linear regression. So to do a linear regression, let me write it down on this page. A linear regression is like using y equals mx plus b. But instead of y and x, we have to use y1. Instead of equals, we have to put a squiggle. So it'll be y1 squiggle mx1 plus b. This is a linear regression. Okay, so you have to type that in, get your information, and answer some questions about it. So they should give you an M and a B, just like the other one will give you an A and a B. And then you write, so let's just, I don't know, make up some numbers. I don't know. Actually, you don't even have to write the equation, but they do need to figure out what R is. So R is like R squared. It's the correlation coefficient. And the correlation coefficient is a number between -1 and 1. If it's close to -1, it's like your data is going like this, going down. If it's close to +1, it's going up. If it's at 0, it's all over the place and everywhere in between. So the different correlations. So they want to know, what is the correlation between, so the correlation R, you get that from Desmos. Okay, and then look at the numbers, see how highly correlated they are. Are they positive or negative? So positive, it would be a positive R, negative would be a negative R. If it was really strong, it'd be closer to 1 or -1. Then you have the R squared. So this one has an R squared as well. When you do a linear, it gives you an R and an R squared. Okay, so find the value and then convert it to a percentage. And then you just have to interpret it. Okay, and then the last question, you calculated the R squared for this fund based on the benchmark index, the Russell 2000 index, which is made up of 2,000 small cap US stocks. Now imagine you completed the same regression using the S&P 500 as the benchmark, which is made up of 500 large US companies. Would you expect the R squared for IWO to be higher or lower? Explain your reasoning. So the first one's made of 2,000 small ones, and then the next one is 500 large ones. Do you think the correlation would be higher or lower? I just want you to think through that one. I can't really help you with that too much. You have to answer that on your own. But hopefully this will help you with this mastery assignment.